Signal flow graph is another graphical representation of a control system. It is the one in which variables are represented by the nodes of the graph, while the relationship between the variables are represented by the branches connecting the nodes. For example, the signal flow graph representation for the equation y equal to mx will be this, and its equivalent block diagram representation is this. Now let us see how we can draw a signal flow graph from a block diagram. Now consider a block diagram representation as shown. To draw a signal flow graph from a block diagram, here input and output signals have to be named as nodes, say x1 and x5. Now name the summing point as one of the nodes, say x2. We have to consider the takeoff point as a single node, say x3. Now if there is no block between the summing and the takeoff point, we can consider this as a single node, say x4. H2 is a feedback branch connecting x3 and x2. H1 is also a special branch called self loop connecting x4 to itself. Now self loop are those loops that starts from a node and ends at the same node having a single branch. The blocks G1, G2, G3 and G4 are the branches connecting the nodes from x1 to x5. Now there are some important properties of a signal flow graph which is to be remembered. If there are more takeoff points from the same signal, then all the takeoff points can be combined and represented by a single node. Now the second property is, if the gain of the link connecting two summing points is 1, then the two summing points can be replaced by a single node. Here you see, we can also see that a signal is subtracted instead of addition. Thus, we should multiply the transmittance by -1 while representing signal flow graph. Now there is one important formula which is also known as Misson gain formula. Overall transmittance or gain can be determined by Misson gains formula, where T equals summation Pk times delta K by delta, where Pk equals forward path transmittance of kth path, K equals number of forward paths, and delta equals determinant of the graph, where delta equals 1 minus sum of individual loop gains plus sum of gain product of all combinations of two non-touching loops minus sum of gain products of all possible triplets of non-touching loops. Non-touching loops are those loops which does not touch the forward path. Now let's practice a simple example of a signal flow graph. In front of your screen there is one block diagram. Here Rs is the input and Cs is the output. We will consider Rs and Cs as two individual nodes. Now we will consider this Rs as a single individual node, say node 1, and this Cs as another individual node, say node. Now here there are two summing points as well as one takeoff point which is below G1 block. So according to the property, we will mark this summing point, these two summing points as well as the takeoff point as a single individual node, say node 2. Now this summing point which is between G1 block and G2 block as a single individual node, say node 3. And this takeoff point which is between G2 and G3 block as node 4. This summing point as well as takeoff point after G3 block, we will consider this as a single node, say node 5. And this Cs as node 6. Now let's draw the signal flow graph. At first, mark all the 6 nodes. Now there is one single branch between node 1 to node 6. So draw one single branch. Now draw a single branch from node 1 to node 6. As we can see, there is no block between node 1 to node 2. We will simply consider this branch as 1. After node 2, from node 2 to node 3, we can see there is one G1 block. So we mark here G1. From node 3 to node 4, we can see there is one G2 block. So mark here G2. From node 4 to node 5, here is one G3 block, mark here as G3. From node 5 to node 6, there is no blocks, we can see. So mark here as 1. From node 2 to node 5, there is another block, say G4. So from node 2, we will simply draw to node 5 as like this. Mark here G4. From node 2 to node 4, we can see there is one feedback loop, say H1. So here we will draw one simple feedback loop. From node 3 to node 5, there is another feedback loop, that is H2. There is one individual loop, that is loop minus H2. We are giving here the minus sign because, as you can see, in the summing point there is subtraction point. From node 2 to node 5, there is another feedback loop. So we will draw here another feedback. Consider this as minus 1. So here our signal flow graph is ready. Now to determine its transfer function, at first we have to find forward path. So here the forward path are, see, from this node 1 to node 6, there is one single branch. Say this one, G1, G2, G3 and this one, we will consider this as a forward path. So we will denote the forward path as P. Say, so P1 will be, so here P1 equals 1 times G1 times G2 times G3 times 1, which equals G1 times G2 times G3. There is another forward path, as you can see here, that this branch is going from 1 to 2, and from 2 it's directly going to 5, and from 5 it's going to 6. So there is another forward path, say P2. So we will write here is 1 times G4 times 1, or you can simply write as G4. So I found out the forward path. Now let's find the individual loop gains. So after forward path, we will find loops. Now we will find individual loop gains. So from here, this signal flow graph has been drawn. So as we can see, this is one individual loop gain. Like this loop is from 2 to 3, and it's going from 3 to 4, and it's again back to 2. Here is also one individual loop gain, that is 3 to 4, and it's going from 4 to 5, and it's again back to 3. So in this way we will determine all the loops. So at first write loop 1. So here we will consider this as a loop. So G1 times G2 times H1. Here there is negative sign, so we will simply put here one negative sign. This is another loop, say loop 2. In this loop we can see that this G2 is times G3 times H2. So here is one negative sign, we will simply put here one negative sign. So let's find out some another loops. This is another loop. So here you can see this loop is moving from node 2 to 3, 3 to 4, 4 to 5, and it's again back to 2. So take this whole loop as loop 3. We will write G1 times G2 times G3 is 1. We will simply put here is minus 1. It's equals to minus G1 times G2 times G3. There is another loop. This loop is traveling from 2 to 5, and it's again back to 2. So take this as loop 4 minus G4. because this whole loop, this 2 to 5 and again back to 2, is just this G4 is getting multiplied by this minus 1. So I have simply written here is minus G4. There is another loop. There is one loop 5. To make you understand better, I simply write here those nodes. You can see this loop is traveling from node 2 to node 5. From node 5, it's traveling to node 3. And from node 3, it's traveling to node 4. From node 4 to node 2. So overall we get here G2 times G4 times H1 times H2. So as you can see, these all loops are touching the forward path. So there are no two non-touching loops. Number of two non-touching loops is 0. There are no two non-touching loops. As I told that all the loops are touching the forward path, so we will consider delta 1 as 1 minus 0, which equals to 1, and delta 2 is 1 minus 0, that is 1. Now using Mason-Gaines formula. So the formula is T equals summation k equals to 1 pk times delta k by delta. In order to find this delta, there is one formula. Now delta equals 1 minus sum of individual loop gain plus sum of gain product of all possible combination of two non-touching loops. What are those sum of individual loop gains? Delta equals 1 minus L1 plus L2 plus L3 plus L4 plus L5. Here there are no two non-touching loops, so we will consider this as 0. So 1 minus, what is the result of L1? That is minus G1 times G2 times H1, and the result of L2 is minus G2 times G3 times H2. L3 is minus G1 times G2 times G3. L4 is minus G4, and L5 is plus G2, G4, H1, H2. Now just simply convert this negative sign to positive, that is G1 times G2 times H1 plus G2 times G3 times H2 plus G1 times G2 times G3 plus G4 minus G2 times G4 times H1 times H2. So here we have got overall result of delta, that is by calculation. Now the Mason-Gaines formula is T equals summation k equal to 1 pk times delta k by delta. We can also write this whole as delta 1 times P1 plus delta 2 times P2 by delta. T equals delta 1 is 1. The result of P1 is G1 times G2 times G3. Here delta 2 is 1 and the result of P2 is G4. We will simply put this result of delta here, that is by calculating Mason-Gaines formula, we have simply got this result. Now guys, today I have solved one example of a signal flow graph. So I request you to solve as much as examples as you can so that you might not face any problem in your examination. Before I end this video, I want to thank you guys for your constant support. And if you have any doubts or problems or any suggestions you want to give to us, please put those in our comment section below. You can free contact to us, and all those details you will find in our description section. Moreover, if you like this video, please hit the like button and share this video among your friends. And don't forget to subscribe our channel if you haven't subscribed yet.